Good evening, students. I think you know about this current situation, and during the lockdown, this is our effort to reach to you. And you have already started some classes, and I know you are eagerly waiting for our physics classes. And before start with our session, I would like to introduce you to our new syllabus, that is 12th syllabus. There are total 10 units starting from electrostatics, then current electricity, magnetic effects and magnetism, then electromagnetic induction, electromagnetic waves, optics, dual nature, atoms, nuclei, electronic devices and communication systems. So today we are not going to start in a wide manner, but we have to start with a little bit starting with electrostatics. So electrostatics is a branch of physics which deals with charges at rest. So you know what is a charge, and in your lower classes you know about you learned about what is charge and what are the properties of charges. I repeat, there are two kinds of charges, positive charges and negative charges. But how you can define a charge, or how matter acquires charge? That is a question. So charge cannot be defined independently. That means charge you can define in terms of charge. That is a special property of charge. The whole universe is made up of matter, and matter is made up of molecules. Molecules are made up of atoms, and atoms are made up of subatomic particles. So when you come to that level, subatomic particles called protons, electrons and neutrons, there comes the property of charge. Protons are having positive charges, electrons are having negative charges, and neutrons are having no charge, zero charge. So there you are finding the particles with charge, but we are not defining what is charge yet. In matter, in an atom, neutral atom, number of protons and number of electrons are same, which means in an atom, number of positive charges and number of negative charges are same. Atoms are not having any charge. But the subatomic particles are having charges. So how matter acquires charge? Even though atoms are not having charge, and the molecules are made up of these atoms, and molecules are not having any charge, but still matter can acquire charge. So how matter can acquire charge? So charge is defined as a property of matter which is acquired by transfer of electrons. I repeat, charge is the property of matter which is acquired by transfer of electrons. And you may be surprised, there are two types of particles, protons and electrons, having positive charges and negative charges. But still I define charge as the property acquired by transfer of electrons. How it happens, or why charge cannot be acquired by transfer of protons? Suppose you are having an atom which having 5 protons and 5 electrons. Protons are present inside the nucleus, and electrons are revolving around the nucleus through their orbits. Since the number of protons and electrons are same, there is no charge at all on that atom. But when you are transferring an electron from that atom to another one, which means now that atom is having 5 protons in its nucleus and only 4 electrons surrounding it. What it means? It has an excess positive charge in its nucleus. So that atom acquires a positive charge. And when one electron is added into its orbit, one electron is added into its orbit, then what happens? Then its nucleus contain 5 protons, and it has 5 already electrons are there, but 1 extra electron is having now. So total 6 electrons having and 5 protons. What it means? It acquires a negative charge. It acquires a negative charge. So that is why I told you, by transfer of electrons you can charge a atom. You can charge a matter by transfer of electrons. In reverse, if or in other ways, you are thinking that if it has 5 electrons in its orbit and 5 protons in its nucleus. Suppose you want it to make an one negatively charged atom. Another possibility is you can reduce the number of protons in that atom, which means you can take away one proton from its nucleus. Then what will happen? In that atom, in the nucleus only 4 protons are there, and in its orbit they are having 5 electrons. So it will become a negatively charged atom. Is it possible? Do you think? No. Why? Because when its nucleus contains 5 protons, it is an element with the atomic number 5. And when you are removing from its nucleus one proton, if you are removing one proton from its nucleus, then its atomic number will become 4, which means you have changed that atom from one to another. So what will happen? It will not give you a negatively charged atom of the same element. Elementary transmutation will happen. So that's I told you in the beginning. Charge is a property acquired by matter by virtue of transfer of electrons. So if you want to make an atom negatively charged one, you can increase the number of electrons there. If you want to make a positively charged atom, you have to remove an electron from that atom. Is it okay? So charge is a property attained by matter by virtue of transfer of electrons. Okay, so now it is clear. I think it is clear to you how an atom or a matter acquires charge. So charge has some properties. I already told you there are 2 kinds of charges: positive charges and negative charges. So these charges have some properties, and we can find out what are the properties of charges. So I advise you to keep a notebook and a pen with you, and you can take down the important points as I discuss now, and the detailed notes we will give to you during the class hours. Okay, so we can start with the properties of charges. I told you charge is attained by matter by virtue of transfer of electrons. So when you are removing one electron, it acquires positive charge. That atom acquires positive charge. And when you are adding an electron in that atom, it acquires negative charge. So charge is the charge acquired by an atom that is very equal to the charge of an electron. The charge of an electron, whether it is positive or negative. And you know, the charge of an electron is 1.6 into 10 to the power minus 19 coulomb. What is coulomb? Coulomb is the unit of charge. Coulomb is the unit of charge. So when you are removing an electron from an atom, it acquires 1.6 into 10 to the power minus 19 coulomb of charge. That is the basic charge acquired by an electron basic charge acquired by matter when electrons are getting transferred. Either it is positive or negative. Are you getting? So when an electron is added into an atom, it acquires 1.6 into 10 to the power minus 19 coulomb of negative charge. When an electron is removed from an atom, it acquires 1.6 into 10 to the power minus 19 coulomb of positive charge. Is it okay? So that property, that is the first and foremost property of charge, that is charge is quantized. Charge is quantized, which means the charge acquired by matter is an integral multiple of basic electronic charge. Why? Because if you are removing or adding electrons to matter or atom, you can't take half of an atom or half of an electron or 3/4 of an electron like that. Am I clear? So if you want to make a matter charged 1, at least one electron you have to remove or one electron you have to add, which means the total charge acquired by matter is an integral multiple of basic electronic charge, which is equal to 1.6 into 10 to the power minus 19 coulomb. Okay, so the first property of charge is quantized, and the second property is charge is conserved. You know the conservation theory of energy. What it means? It says the total energy in the universe is conserved. Energy can be transferred from one form to another. Similarly, quantization of charge means the total charge in the universe remains constant. Which means charges can be transferred from one system to another. But in the whole universe, the total charge remains same. Okay? So when charge is removed from one, suppose electrons are removing from one atom, that electrons are acquired by some other atoms, which means the atom which is losing electrons acquires positive charge. The system which acquires that electrons gets negative charge. So charge is quantized and charge is conserved. The total charge in the universe remains constant. Charges cannot be created nor be destroyed. Another property is charges can be additive. Which means suppose you want to make an atom 5 negative charge. If you want to make an atom 5 negative charge, it is not necessary that 5 electrons you have to remove at once. You can take first one electron. If you want to make it a negatively charged, you can add one electron there and another one, then another one, then another one like that. Which means charges can be additive. If you are adding first electron, it acquires one negative charge. If you add another electron there, it acquires another two negative charges like that. And if you want to make it 5 positively charged one, what to do? You have to remove electrons from its orbits. That also can be done one by one. That means charges can be additive. And as you know, same charges will repel and opposite charges will attract. That means when two positive charges and when two negative charges come together, what will happen? They will obviously repel each other. And when a positive charge and when a negative charge are come close together, then what will happen? They will attract. So similar charges will repel and opposite charges will attract. That is another property of charges. That means charge is quantized, charge is conserved, charge is additive, and similar charges will repel and opposite charges will attract. And again, we can come back to our definition of charge. Charge is the property acquired by matter by the transfer of electrons. Remember, by the transfer of electrons. Okay, so we have said that there are two types of interaction between two charges. How these charges can interact? If two similar charges are there, they can interact repulsively. And if two opposite kind of charges are there, they can interact attractively. That means they can interact through forces. They can interact through forces. Which means when two similar charges come close to each other, there is a force of repulsion between those two charges. And when two opposite charges are come close to each other, there should be an attractive force. Anyhow, there should be a force between two charges. Either it may be negative or positive. So how you can find out the force between two charges? How you can find out the force between two charges? And last syllabus, that means the 11th syllabus, you have already learned about the force existing between two masses. And the force between two masses can be easily find out using gravitational law, Newton's gravitational law. Similarly, very similarly, force between two charges can be find out using another law which is very similar to your gravitation. What it says? It says that force between two charges, whether it is positive, means repulsive or attractive, no problem. Force between two charges is directly proportional to product of these two charges, that means individual charges, and inversely proportional to the square of the distance between these two charges. In other words, we can say force between two charges directly proportional to the amount of charge and inversely proportional to the square of the distance between them. It is also an inverse square law, as in the case of a gravitational force. And this law is known as Coulomb's law. It is known as Coulomb's law. And Coulomb's law states that the force between two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between two charges. Remember, charges are generally represented by small letter q. Generally, we are using the notation small letter q for representing charges. Suppose Q1 and Q2 are two charges separated by a distance r. You know that means many times we have derived this kind of equations in the case of our gravitational force. Anyhow, remember Q1 and Q2 are two charges separated by a distance r. What Coulomb's law says? The force between them is directly proportional to Q1. Force between them is directly proportional to Q2, and force between these two charges will be directly proportional to 1 by r square. Remember, it is inversely proportional to r square and directly proportional to 1 by r square. So we can club all these three matters together. So F proportional to Q1 into Q2 divided by r square. And that proportionality you have to change into an equality. How to do what to do to make it an equality? Adjust with a constant. And here we are using a constant 1 by 4 pi epsilon. 1 by 4 pi epsilon. So that constant is 1 by 4 pi epsilon. So the force can be expressed as F is equal to 1 by 4 pi epsilon Q1 Q2 divided by r square. You are surprising what is this epsilon. I will explain to you. Epsilon is property of free space, and that is known as permittivity of free space. If it is a free space, that epsilon, it is denoted as epsilon naught, and if it is present in any medium, then it will be expressed as epsilon. Epsilon means the permittivity of the medium in which the charges are present. Okay, so Coulomb's law states the force between two charges is equal to, F is equal to 1 by 4 pi epsilon Q1 Q2 divided by R square, where Q1 and Q2 are the two charges, R is the distance between them, and epsilon is the permittivity of the medium in which that charges are present. Okay, so that's all for today, and we will meet.